Hi, what we're going to do today is start chapter 9, and so we're going to look at adding and subtracting polynomials. Now, we did talk about this at the beginning of the year with like terms, so hopefully you guys just kind of remember what we were doing there, and then we're just going to apply it. So some of this is new stuff, though, so we have some new definitions, but the basic idea of adding and subtracting is not new. First of all, what is a polynomial? Well, a polynomial is a monomial or the sum of monomials. And a monomial then is just a variable or a number or the product of them. So it's important that you know it's the product. So a monomial then is just considered to be one term, and there's not a plus or a minus inside of it. So you could have, so we're adding or subtracting monomials. But here we're looking at polynomials then. So yes, this first term here, the 3x, is a polynomial, but because it only has one term in it, it's also referred to as a monomial. So it's both a polynomial and a monomial.
Which I'm not going to try to write.
It's not erasing. All right, so the second one then, 3x plus 4. So both the 3x and the 4 separately are considered monomials, but when you combine them with a plus or a minus sign, you get a polynomial. So here's an example of a polynomial, 3x plus 4. On the next one, x squared minus 2x plus 1. So this particular polynomial has 3 terms in it. So x squared, then you have the term minus 2x, and then plus 1, so it has 3 terms. So you have 3 monomials are combined to make this polynomial, and when it has 3 terms, the prefix is called tri, so it's a trinomial. And then the last one is another polynomial, but it's the sum of 2 separate terms. And so because it has 2 terms, then the prefix is bi, so it's a binomial. All right, so we have examples of monomials, binomials, and trinomials, but they are all considered polynomials. And then you can have polynomials with more than 3 terms also. We just don't have specific names for them.
All right, so let's look at an example of things that are not polynomials. So this first one we have is 2 divided by n. This is not a polynomial because the monomial cannot have a variable in the denominator. So right here, that cannot happen, so this makes this not a polynomial. On the second one, 1 over x to the 1/2, well, we haven't really talked about this, but when we have x to a power, we need these powers to be whole numbers. And so in this case, this 1/2 is really asking us for the square root of x. And we will get more into that later, but the important fact is when you have x to a fraction power, that is also not a polynomial. Down here, we have 4 to the a. And this is not a polynomial because we cannot have a variable exponent. So the fact that this 4 is raised to the a power makes it not a polynomial. And then this very last one, well, you know when you see a negative exponent, you make it a fraction. So we have 1 over x. And again, we cannot have our monomial in the denominator, so this is not a polynomial.
Okay, so because we have different exponents, different values of exponents on polynomials, we refer to a polynomial as the degree of a polynomial. So the degree is the greatest degree of its terms. So basically what you have to do is look at the degree of each term, and then you just take the largest one. You don't add those all together. So in this polynomial here that we have written here, it has 4 terms in it. So we have a 2x cubed. So that particular term has a variable, or has an exponent of 3, so then we say that that term has degree 3. The second term is an x squared, and so it has degree 2. The next one, negative 5x, has degree 1 because we have a little exponent of 1 even when it's not shown. And then the 12 is degree 0, so it's like, remember, an x to the 0 power. And so we have a degree of 3, 2, 1, and 0, so you take the largest degree, which is the 3. So that whole polynomial is a third degree polynomial. So you do not add the separate exponents. And then another term that you need to know is the leading coefficient. And the leading coefficient is the coefficient on the highest degree term. So in this case, the very first one, the 2x cubed, is our leading term. And so the leading coefficient then is positive 2. The coefficient is just the number in front of the variable part.
All right, so now that we know the way polynomials need to be written from highest power to lowest, let's practice rewriting a couple polynomials. So we look at this first one, and let's look at the degrees on each of the different terms. So 15x, well, that has a degree of 1. And then we have minus x cubed. Obviously, that has the third degree, and plus 3. So that would be an x to the 0 degree. So we just have the 0. So our highest one is our x cubed. So that's what's going to come first when we write this. So we're going to have negative x cubed. And then we're going to put on the next highest power. Well, it's this 15. Now, there's not a sign in front of the 15, which means it's positive. So that means we're going to add it. And then we will add our lowest degree term, which is just our constant 3. All right, let's try another one. Again, we look at each of the terms, and we identify the degrees. So the first one is the 2, and then our next one is a 3x cubed, so obviously our degree is 3. And then we have minus a constant, so that's a degree of 0, so it's like having an x to the 0, which you guys know anything to the 0 power is 1. So then again, we rewrite this with our highest one coming first. So that will be our 3x cubed. And then there's nothing in front of this 4x, so it's positive. So plus 4x squared, and then minus our 9. Minus 9, like so.
Okay, so here we have some examples of different expressions, and we want to know if it's a polynomial or not. And then if it is a polynomial, then we're going to classify it, and we're going to classify it by the degree of it and also by the number of terms that it has. Okay, so the first one, so our expression is just a 9, and so is that a polynomial? And a polynomial is, once again, a number or a constant or the product of those. So that is a number. So yes, it is a polynomial. And so when we classify it then, the degree is 0 because it doesn't have a variable there. So the degree is 0, and it only has one term in it, so we refer to it as a monomial. So it has one term, so it's a monomial. And yes, it is also a polynomial, though. Okay, so on the next one, I have 7b c to the third plus 4b to the fourth c. So is that a polynomial? Well, we're not dividing by any variables. We don't have a rational exponent, so like we don't have fractions, we don't have negatives, we don't have variables as exponents, so yes, it is. That is a polynomial. Now, this one is a little bit different. We haven't talked about a degree on one like this because we have different variables in there. So if we just look at the first term, the 7b c to the third, well, not only do we have an exponent of 3, but we also have a variable there of b, and so the exponent on b, if it's not written, is a 1. So for that particular term, that first term, we have to add the 1 and the 3 together, so that gives us a degree of 4. So just that first term has a degree of 4. And then if we look at the second term, 4b to the 4th c, well, once again, we have a c without an exponent written on there, so we know then that's an exponent of 1. So we have to add the 4 and the 1 together, so that term has a degree of 5. So now we look at the separate terms then. We have a degree of 4 and a degree of 5, so we take the largest of those. So it's a 5th degree, so the degree is 5. And to classify this polynomial, well, we classify it by the number of terms that it has, and it has 2 terms in it, so it's a binomial. All right, binomial, but it's a degree 5. Okay, the next one, 6n to the 4th, so that is a monomial, but our second term, the 8 to the n, that is not a polynomial. Remember we said that you cannot have a variable exponent. So this one is not a polynomial, so therefore we do not classify it. Our next one, we have n to the negative 2. So our exponents can only be whole numbers, so we can't have a negative exponent, because remember that'll make it, you would simplify that by making it 1 over n squared, and we cannot divide by variables, so that one is not a polynomial either, so we don't classify it. Okay. The last expression, 2x squared, so that first term has a degree of 2. The second term, just the x, has a degree of 1. And then the third term, the minus 5, a constant term, has a degree of 0. So we take it is a polynomial then. So yes, that is a polynomial. The largest degree is 2. So it's a second degree polynomial. And because it has 3 terms, it's referred to as a trinomial. So 3, remember, like a tricycle or a tripod, so a prefix of tri means 3, so it has 3 terms, so it's a trinomial.
All right. Let's look at now what we do when we add polynomials. So here we have 2 polynomials, 4x squared plus 3x cubed minus 9, plus another polynomial, 2x squared plus plus x cubed plus 5. Now, back in the beginning of algebra, you learned you can only add like terms. The same is true with polynomials. We can only add terms that have the same exponent power. So, because this is plus, we know that we don't need to change any of the signs, and we can kind of start to rearrange our expression because we know that addition is associative. So the first thing we'll do is we'll put all the x cubed, because that's our highest degree, terms together. So we have 3x cubed from here, and then we have plus x cubed from here, and then we have 4x squared, and I don't know if I'm going to have enough room, so I'm going to carry it down. So here, and then I'm just going to have it plus down here, and I'm sorry about that, plus 2x squared, and then we have minus 9 and plus 5 left. So then we will start to add like terms. If we have 3x cubed plus 1 more x cubed, because remember there's that invisible 1 when there's not a coefficient there, that would be 4x cubed. And then we'll look at the squared terms. We have 4x squared and 2x squared. So we add the 4 and the 2, and we'll have 6x squared. And then minus 9 plus 5. So negative 9 plus 5 is a negative 4. So that is the answer. 4x cubed plus 6x squared minus 4 is adding our first two original polynomials. So let's try this once again. Because we have a positive sign here, we don't change any of our signs within our parentheses, so then we can go ahead and start to rearrange it to put the like terms together. So we'll have x squared plus 2x squared. Now it's important to remember that this is a negative 3x, so we're going to keep it as minus 3x. Oh, and I forgot we have an x cubed term, so we'll have to rearrange again. So minus 7 plus 5, and then I'm going to tack this guy on at the end since I forgot him. X cubed. So when we start to rewrite it, we have nothing to add with that x cubed term. So that guy comes first, right here. And then we'll add our x squared terms together. So we have, remember, that invisible 1 right here. So 1 plus 2 is 3, so we'll have 3x squared. And then we have nothing to add with this negative 3x, so that guy will stay the same. And then minus 7 plus 5 is a negative 2. So here, and if you guys were paying attention, we took two different polynomials and we added them to the same one and got two different results. And this is because there's different terms, and you can only add like terms.
So subtracting polynomials works a lot the same way, so we can only subtract like terms, but we need to be careful. Whichever one we're subtracting, you have to make sure and change all of the signs. So we're going to take the first polynomial in parentheses and we are going to rearrange it and put it in descending powers of the variable. So let's start with a negative 2x squared, and then we go down to the 3x, so plus 3x, and then minus 5, plus 5. And then, now on this next one, when I subtract those then, I'm going to get rid of the parentheses, so I'm going to change the signs as I subtract it. So I want to subtract a positive x squared, so it's going to be minus x squared. And I want to subtract the 2x, so it's going to be minus 2x. But then I want to subtract a negative 3, which ends up being adding 3. So you go plus 3. Okay, so anytime you're subtracting, make sure and change not just the sign on the first term, but make sure and change it on all of the terms of the polynomial that you are subtracting. Now I can combine like terms. So let's underline the like terms. So I have a negative 2x squared, so that is like to the negative x squared. So those are like terms. So when we combine those, we get a negative 3x squared. Okay. Now let's take the next like term. So I see I have a 3x there next. So I'm going to combine that with the like term in the other polynomial, which is a minus 2x. So 3x minus 2x is plus x. So we get plus x. And then our last like terms are the constant terms. So I've got a plus 5 and a plus 3. So when I add those together, I get a plus 8. Okay, so now I've subtracted those polynomials, and then we put the answer in descending powers. So the highest power is the x squared, and then the x, and then the term without the x. Okay, so that's usually how you want to write your answers unless it tells you otherwise. Every now and then it might say put it in ascending powers, but for the most part, if it doesn't say, that's how we want it to look with the descending powers. Okay, so this one then, we're going to rewrite it as we go along if we need to. The first polynomial, though, is already in descending powers of the variable, so I don't need to make any changes. So x squared minus 3x minus 7. Okay, so we have two jobs here. We're going to distribute the negative because we want to subtract, and we want to rearrange it. So the highest power on this one is the x cubed, so I'm going to put it first. So I'm going to go minus x cubed, and then I'm going to go minus 2x squared, and then I want to subtract the 5. Okay, and at this point it's not crucial that you put that particular polynomial in descending powers, but we just went ahead and did it, so maybe it'd make it easier for us to find the like terms. Okay, so I look for like terms. I want to take the highest degree first of all, so I look through that polynomial and I say I only have one term with the exponent of 3, so that's the highest power we have, so that one needs to go first. I've got nothing else to combine with it, so negative x cubed. Okay, so I'm going by descending powers, so now I'm looking for my powers of 2. So I've got the x squared term, and I've got the minus 2x squared, so those are like terms. So 1x squared minus 2x squared gives us a negative x squared. Now I look for the next lowest power, so now I just need the powers of 1, and it looks like I only have one of those, that minus 3x, so I've got nothing else to combine with it, so that term comes next. And then I look for the terms without an x, and I have 2 of those. I have a negative 7, and then I have a minus 5 there. So minus 7 and minus 5. So when you combine those, you get minus 12. So there is our simplified polynomial.
All right, let's look at an example of doing geometry with polynomials. So here we have a parallelogram, and what we should all know at this point about parallelograms is the opposite sides are the same length. So this side and this side are the same length, and it is true about all of the sides. So this side is the same length as this side. So what we want to do with this is we want to find the perimeter. Now, to do this, we've got to remember, okay, how do we find the perimeter? And all of you should know by now that to find the perimeter, we add up all the sides. So we know that we have 2 sides that are a length of 3x plus 2. And then we have to add to that the other 2 sides.
Good morning, Windsor.
All right, sorry for the interruption. Like we said, we're going to have 2 of the other sides. So that's going to be 2 times 4x minus 1. Then we are just going to do the mathematical computation, so distributing the 2's. So that'll give us 6x plus 4 plus 8x minus 2. So now we will combine like terms. So we have 2x terms and 2 constants. So 6 plus 8 is 14, so we'll have 14x plus 2. And that is what our perimeter is equal to as a mononomial. So our perimeter is 14x plus 2. I hope you enjoyed this math lesson on mononomials, and make sure you write any of your questions down and bring them to class, and have a wonderful day.